Hello, I'm by the name Building. I'm here to explain the determinant of the matrix. I want you to know more about the determinant of the matrix, about the 2 by 2 matrix, 3 by 3, so that you can know more about it. That's what I want to say. A determinant is a number calculated from a square matrix. That is the determinant. It is calculated from a square matrix. You make a matrix to be a square, then you calculate it to get the determinant of the number. Then it helps us to solve the system of the equations and then find the inverse of the matrix. Then they determine if the matrix is inversible. So we shall start by the explanation of the 2 by 2 matrix. Introduction to the formula. When you're doing 2 by 2 matrix, like when you are multiplying to find the determinant, you start with A times B. Yeah. And B times B. Then minus D B times C. Then it will be equal to our determinant of the matrix. So that's how we find the determinant of the matrix. Of 2 by 2 matrix, it is easier. It is more simple than to find the determinant of 3 by 3 matrix. So let's go to the example. We try to solve the example. The example is matrix A is equal to 3, 2, 1, 4. Then how to find the determinant of the matrix? Then we shall say the determinant is equal to 3 times 4 minus 2 times 1. Then it will be equal to 12 minus 2. Then our determinant will be equal to 10. So that's how we find the determinant. And also, we can try another example of 2 by 2 matrix, which can make our work to be more and you can understand more. Like let's try to create another matrix. Let's put here 2, then 5, then 1, then 6. Then our determinant will be equal to 2 times 6 minus 5 times 1. Then it's going to be 12 minus 5, which our determinant is going to be 7. So this is how we make the 2 by 2 matrix. So the next is we shall find out how we can multiply the 3 by 3 matrix. On the 3 by 3 matrix, we make it to be 3 rows, 3 columns. So that's how 3 by 3 matrix is. So when you're finding the 3 by 3 matrix, like the way it is 3 rows, 3 columns. So when you want to find, so you first eliminate the first row, then you say A. Then when after eliminating, then you say that to find the A, then you need to remove row 1, then column 1. Then after removing, then you are remaining with E, H, F, then I, then minus B, then minus B. To find the B now, find the B, then you will say that you need to eliminate column row 1, then column 2. Then you remain with D, G, F, and I. So that's it. Then now we go next plus C. So how to find the C? You eliminate row 1, then column 3. Then you say that the remaining is D, E, G, H. So that's it, how you can find it. So now let's go to the example. The example of 3 by 3 matrix is 1, 2, 3, 0, 4, 1, 0, 4, 5, 1, 0, 5. So how to find it? Let's start with, we need to find it. Then we shall say that 1, then we remove row 1, column 1. Then we say that 4, 5, 0, 6. Then minus, then you remove minus 2, you remove column 2, row 2. Then it's going to be 0, 1, 5, 6. Then plus 3, Then you remove the third column, then the first column. Then it's going to be 0, 4, 1, 0. So this is it. Then now when we are multiplying, 4 times 6, then 5 times 0 minus 2, 0 times 6 minus 5 times 0. Then the result will be this. So to getting the results, then now you make it to be simple. You say 24 times 1, 2, negative 2 times negative 5 plus 3 times negative 4. Then it's going to be equal to 24 plus 10 minus 12, which is going to be equal to 22. That's the answer you get. Because when you add 24 plus 10, then it's going to give you 34. 34 minus 12. 34 minus 12, you will get 22. So that's why we got 22. So the application of determinant is applied on some other ways. Solving the linear equations, like when solving the linear equation, you can use the determinant to solve it. Inverse of matrix needed in engineering and computing, like it is needed because we are doing engineering and computing. Then geometry, finding the area of triangle, you need also to find the determinant. And also the example that if the determinant is equal to 0, then points are not collinear, so they will not be collinear to each other. So that's how it is. Then the key point that you need to know, if the rows are equal to the determinant is equal to 0. If the determinant is equal to 0, the matrix has no inverse. Then swapping rows changes the sign. When you want to swap the rows, like when you have 4, 5, 6, 7, then you swap the rows. Like you can swap, you bring the upper row down, then the down row you take it up, then you say 6, 7, then 4, 5. So this changes the sign when you change the rows. Then in conclusion, the determinants are very useful in matrix in mathematics and in real life applications such as solving equations. Yeah, they can help you to solve many equations, solve your work so that they can help you. So I think this is the end of my presentation. And if there's any question that you need to know, you can ask me and I will let you know more and I will explain more to you.